Okay, it's the fourth week of this class. Okay, so in the first three classes we talked about security management problems. Okay, and we started to introduce several different errors, including the most basic one, linear regression, and we discussed how do we measure the performance of different algorithms. For example, we use a loss function, which is MSE, mean square error, to compare different algorithms. Okay, and the second one is still very basic, which is logistic regression. Okay, for linear regression and logistic regression, we may make some we may have a comparison. Okay, so draw a table, which might be good. Okay, linear. Okay, logistic. Okay, usually we draw linear regression like this, right? We have a y, we have an x, several different x. Right? We visually believe we can use a line to represent the relationship between the features, which is big X, and y. And this y is a numeric target, right? And on the other hand, logistic regression looks like this. We have a binary class. Okay, the label is 0 and 1. Okay. And the line looks like a Z shape. Okay, reverse Z shape. Okay, and y is a categorical target. All right, and for linear regression, y equals a x plus b, of course. Y something like that. Okay, the shape is different. However, these two different errors, they both follow the same philosophy. 他们有个共同的我们说哲学的概念吧。Okay, they want to model the relationship between x and y by using a curve or a line or a surface, which is okay, to fit the original data, which is x and y, by using a more simpler surface or a line. 我们是希望它在描述原本的资料的时候呢，用的是一个 shape， 一个线或是一个 surface， 一个平面，一个面去描述 x 跟 y 之间的关系，尽量希望它能够贴合。我们用 fit 这个字，希望能够贴合。So that we don't have to record every data point of x and y. We only use a very simple line or a curve or a surface to describe this relationship between x and y. So in the meantime, we can do what? We can do prediction, which means given x, I can predict y, no matter it is a numeric target, so that we can use linear regression to predict y by using input x. Similar, okay? We still can use x to predict a class or a category, okay, labeled by 1 or 0. If you input x features, okay, and we use this Z-shaped line to describe what is the relationship between x and y, so that we can predict its y. Okay, still this is a prediction. However, today, okay, we will introduce another different algorithm. The philosophy is a little bit different. Okay, we call it SVM. Okay, it's right here. Okay. So the idea of SVM is like that. Okay, I still have several different features. For example, like x1. Okay, that is x2. Okay, make sure you notice that the surface right here is both features surface. There's no y. Okay, so the y here is that y. For example, it's purple. Okay, and this y is green。啊，你要注意哈，我们现在在讨论 SVM 的时候，它的 surface 是没有 y 的哈，它只是 x feature 的平面哈，或者 feature 的空间啊。那 y 是在通常是画成颜色 ，OK， we use color to label those data points， OK。So of course for simplicity， 就是为了简单化，我们就弄二维就好了哈。We use only 2 dimensions to describe this problem， OK。So the question is that could we simply just find a line or a curve? Okay, of course it is a simplified example, so we demonstrate in the in only 2-dimension space. 好，我们只在为了简化，我们现在只在二维的空间里面讨论哈。To divide these classes, so visually, okay, we can draw a line, okay. However, this line does not reflect the relationship between x and y because we don't have y in this surface. In this surface, okay. This line, it specifies a surface or a line or a space, subspace. 那要看了，如果是平面的话就是线哈，如果是空间的话是一个面，如果是多维空间的话就是一个子空间啊。This line, this surface or this subspace can divide the data with different labels, okay? In to separate these two different set of data. OK， 它可以用一条线、一个面或是一个曲面或者一个子空间，把两部分不同的资料 label 不同的资料把它区分开来。OK，that is another kind of philosophy. OK，so the question is, how do we find such kind of line? To find such kind, it is quite straightforward to deal with such kind of problem. OK， 就是我们要用前面那个 philosophy， 就是把 x y 呢就硬挤在一个曲面上或是一个线上。去 fit 它，其实这个问题，就是描述原本的资料嘛。可是这个不是，这个问题比较特别，它不是要描述这个原本的资料，它是找一个最佳化的线或曲面把它分开来。所以这条线有表示 x 所有的资料吗？并没有。好，我英文再讲一遍哈。The philosophy of this kind of algorithm is a little bit different from linear regression and logistic regression. Right here, we find a surface, a line, a subspace to separate these two different data sets. We do not describe the relationship between x and y, which is its target. Okay, so we describe a line which can partition this data, these two set of data. Okay, so a linear discriminative classifier. Okay, so this line can be used as a classifier. 可以被视作一个分类器。We'll attempt to draw a straight line, separate two set of data, and thereby create a model for classification. So that is very important. The model we create right here is only for classification. We not use this model to describe the entire data set. 好，这个可以理解吧？我们是用这个模型来描述一个分类的方法。我们不是用这个模型来描述原本的 x 跟 y 的资料，对吗？你看这条线如果一直都在的话，即使我随机的拿掉一个绿色点跟一个紫色点，如果那绿色点跟紫色点其实无关紧要的话，那条线还是在嘛，对不对？那条线还是在，你不会因为拿掉了一个绿色点影响这个区分太多嘛？如果那个绿色点不是太重要的话，好吗？所以我们不是描述资料，我们是描述这个分类的现象。But we see a problem here. There is more than one possible dividing line that can perfectly discriminate between these two classes. Okay, so the algorithm we use right here is called SVM, which stands for Support Vector Machine. Okay, rather than drawing a zero width line between the classes, we can draw around each line with a margin with some width. Okay, so let's take a look at this one. So ideally, there are a lot of different lines which can partition these two data sets, right? But However, visually, okay, the green one, we believe the green one might be the best one because it has the widest width 啊，就是视觉上我们现在要区分这两个点嘛，那你随便画很多条线都可以啊，但是就视觉上来说，你一定觉得绿色最好，为什么？因为它最宽嘛。好，就是 that is the idea of SVM. How do we find such kind of line which has the widest width that can partition these two data? OK， 好，这个就是这样子哈。OK, let's take a look at this one. So basically, basically it is a surface. So make sure you understand that is x0, right? That is x1. Okay, so y is right here. Y is right here. All right, y is labeled by color. Okay, so we'll have to find a best line, which is this one. This is a classification model, so it is a line. Okay, and we can find several different lines. Okay, but we believe this one is best. Why this one is best? Okay, because it has the widest width. Okay, so there are two additional lines. Okay, which is right here, the first one, and the second one is right here. Okay, so when we want to calculate the width, we need these two support lines. 啊，就是我们要算宽度的时候啊，你就一定要把宽度画出来嘛，对不对？那宽度最宽一定是顶到两边的点嘛，对不对？就是那些圈起来的点啊，就是我们就可以算宽度。这两个线是辅助的线啊，辅助的线。So how do we calculate this one? Okay, take a look at this one. In general, okay, we just use general terms to describe this problem. 好，所以下面这个是一般式哈 ，general term. Okay, how do we describe a line in the surface? Okay, W transpose x plus b. Okay, what does that mean? This green line, okay, usually we use y equals ax plus b, right? But we know we have a lot of different features, so it should be a surface. It should not be only two dimension. It should be multi-dimension, right? So x, usually the x is represented as x0, x1, x2, x3 to xn, for example. And we have a weight, right? Like a. Okay, so we have a weight here, weight 0, W1, W2, W3 to Wn. And of course we have B, right? So it also B0, B1, B2, B1. So basically, okay, if we do this calculation in an m dimension space， 好，如果我们在一个 m dimension 的话，它应该是比较复杂的。好，实际上 it looks like this: y equals W0 times x0 plus W1 x1 plus W2 x2 and so on and so forth. Right? However, it is a little bit complex, so we usually, okay, we write it in a more matrix way or vector ways. So basically, it equals to we transpose 啊，就是我们先翻过来，先把 W 翻过来 transpose what W, so it looks like transpose dot product, okay, the x, and then we plus b. Okay, goes to y, something like that. Okay, so if of course we can make some arrangement by with the b and y. So here we have a general representation of a line, which is W transpose dot x, which is a vector, plus b equals to 0. Okay, that is a line. Okay. So since we have two other support line right here, okay, so we can say that it is W transpose dot x plus b equals to minus delta n equals delta。他们俩是平行线嘛，对不对？所以他们的斜率应该是一样的嘛，所以他们 W 应该是一样的嘛。可是他们高不太一样嘛，所以他们截距不太一样嘛。那因为他们两个距离相等嘛，所以我们就假装一个是正的 delta， 一个是负的 delta。那但是 delta 跟 B 会做加减啊，这样做加减之后，他们就会得到两个不同的截距啊，所以他们就会是平行线。OK。So ideally, okay, there should be one or more. 好，注意哦，特别要注意哦，一定是一个或多个啊，这个英文里面有讲哈。There should be one or more points, which is the original data, touch the support line, which is right here, and right here. Of course, with different slope, with different setting of W, okay, different point will be touched by the supported line. 好，中文再讲一遍哦。就是因为我们是在算最宽的距离嘛，哈，所以一定会有两侧的那些点，哈，就会碰到那个辅助的线。那当然根据斜率的不同啊，斜率不同就是那个 W 的不同，哈。那你斜率不同的时候，你那条线会旋转嘛，对不对？那有可能会碰到不同的点。好，那我们现在就是说，在这个斜率不同的情况之下，会两侧会碰到不同的点。它到底碰到哪一些不同的点的时候，这个宽度会最宽呢？这就是 SVM 想要找的那条线。OK。For those points, okay, those very important points, although they looks like a point, but actually it is a point in a multi-dimensional service, a multi-dimension space. So we call it support vector, and it should be S because we will have a lot of points, which is support vectors, to help us to find those lines, those support lines, and help us to calculate the width of the SVM line. 好，就是我们要用这些碰到的点来帮助我们算那个距离。Okay. So right here, take a look at this one. Since we can always divide the above equation by delta, we can simplify the equation as follows. Okay, we can simply just divide those equations by delta, so let the delta disappear, right? Without generosity, 就是在不失一般性的情况之下，那个 delta 其实一点都不重要，所以我们就把所有式子所有参数全部除以 delta 就好了嘛。反正 W 我们还没算出来嘛 ，B 我们还没算出来嘛，我们就把它 delta 全部都除掉就算了啊。那反正这样还是一条线嘛，还是一条线。所以呢，那个 delta 就不重要，我们就把它全部换成1了。Okay, so the equation is like that: W transpose times X plus B. Okay, if it's less than 1, okay, less than 1, which means it's green line, it's green point. If it's larger than 1, okay, so that is this line is WT transpose X plus B, right? So at the bottom half, okay, the Y is less than 1. At the top half, the Y is larger than 1. 好，这个高中你们都学过嘛，一条线的两边嘛，好，那个 Y 值一个就是大于的那一边嘛，那反面那边就是小于的那一边嘛。然后我们就会有下面这个式子，其实不是一般性是一模一样的。Note that, okay, note that the data point in the above figure is x0 and x1 啊，就是注意哈，这个平面是没有 y 的哈，我们 y 是用颜色做label。We use color to represent y. Actually, y is not on the surface. Okay. So for simplicity again, we can represent the above equations as follows. Okay. 就是你认真注意看哈，就是因为我们现在两个不等式嘛，两个不等式会 imply 会导出不同的 y 嘛。可是这不等式其实你注意看，你把它前面乘以 yi， 就是乘以那个 y 的值的时候，刚好这两式会是相等的。If let's take a close look at these two equations and the below one, okay, they are the same. Okay, they are the same. Okay, if you use y equals minus 1 and you put it into the below equation, it's the same. If you y equals to +1, and you put y in the below equation, is the same as the above one. 好，这两个式是一模一样的，好，这个是不等式的结合而已，好，没有什么特别的。So we have a constraint right here. Okay, if we model our problem by using SVM, then we have a constraint right here. yi times wtx plus b. Then it should be larger than 1. Okay, it is a constraint right here. So if we find those support vector, okay, which is one of the support vectors right here, the other one is right here, okay, we give it a label called x minus and x plus, which means this support vector is in the negative side of this line, and x plus means this support vector is at the plus side of this line. 啊，我们就是说，我们就 x 减的意思就是说，这个 support vector 应该是在负的那一面的，啊，就只是个代号而已啦，啊。So if we connect two support vector, and one is x minus, the other is x plus, 啊，就是我们随机选两个 support vector, 然后是各占一边的 and we connected these two lines, and it create a vector, which is the black one right here, right? A black one right here. And the green line is the line we like to find, which is a support vector machine line. Okay? So if we make a projection of this black line, x plus x, this line we call x minus x plus, which is a vector, right? And this line is w t x plus b, right? If we make a projection by using x minus x plus and project it to the tangent line of wt x plus b, 好，中文是说，如果我们用 x 减 x 加的这条线的向量去做一个 projection， 就是投影在那一条绿色的线，就是我们要找的那条最棒的那条 SVM 的线的垂直线上，我刚刚讲是 tangent line 哈，垂直线上 ，then we get this blue line, which is w vector。那大家知道哈，那个线的那个在方程式里面嘛，如果你的那个线啊，就是斜率啊，或者是就那个 w 了哈，我写成 wt 的时候，它的那个垂直线刚好就是 w 嘛，啊，因为它刚好是 transpose 嘛，可以吗 ？So here we have a function, objective function we would like to optimize. 所以现在我们就找到一个 object， 就是目标函数，然后我们要最佳化它。最佳化什么？就是当我们找到这条蓝色线的时候，我们希望它的长度是最大的。哎，它就突然变成一个optimization， 就是一个最佳化的问题了，就是在这个曲面多维空间里面一个最佳化的问题了。找掉一条 wt 跟 b 的线，使得 x 加 x 减的配对的投影，也就是 w 的长度会是最长的，那这就变成一个简单的那个 OR 的问题嘛，啊，就是一个最佳化的问题。然后还记得吗？我们刚刚上面有个 constraint， 有没有一个 yi 乘以 wtb x 加 b， 然后两个乘积要大于等于1的？哎，这刚好就是限制式的。好，如果你没有学 OR 的话，应该会对这种东西不是很陌生哈。好，英文再讲一遍啦。So SVM becomes a optimization problem, which is in the surface we have a lot of data points departed in two different sets, green and purple. How do we find a line wtx plus b, which to find those parameters? That if you can find the vector, support vector x minus x plus, and you do the projection, get the blue line w vector. The objective function is the length of this projection, which is right here, which is the width. we like to maximize this width by adjusting W and B. How can we find W and B to create a line? And this line can have a maximum width. 就是它就变成一个最小化的问题。And don't forget this. This one. When we find such kind of line, such kind of W and B, okay, there is a constraint which is yi times wt x plus b should be larger than 1, which is the condition when we find this best SVM line. Okay, so it becomes a optimization question. Okay, problem. So the math is like that. What we would like to calculate the width. So we use this line, which is the black line, right? Black vector. And here, that is the projection, right? The projection. So after that, the width is right here. Okay, so we'd like to maximize this value. So right here, we would like to maximize this value, right? However, as we show you before, to maximize something is not that easier because differentiation 就是微分哈 can help us to find the minimum value. So take a look at this one. If we would like to maximize something, okay, maximize this one, and we can write it in this way. We can minimize these things. 就是2 over W vector. Okay, we have to maximize this value. Okay, and we can minimize the below one. 这两个当然不是相等的，它的意思一样嘛。你要最大化一个在分母的值嘛，那你就最小化它在分子的值就好了嘛。那你要做最小化的时候呢，你又希望里面最好是可以被微分的，微分起码要平方以上就比较简单嘛，对不对？所以你就把它平方，因为一个值的最小化跟它平方的最小化其实意思是一样的意思，所以它们只是等价而已，这只是数学上的技巧，它们并不是真的相等。这个前面那个等号不是那个意思，它只是说你可以这样做，也还是可以得到那个最大化的那个宽度最宽的宽度。那大家看得懂这前面这 argue 吧 ？argue max 的意思就是说，我在找到后面这个的最大值的时候，请你帮我把那个 W 参数找出来。好，那个 W 参数里面的东西就会变成，其实这边可以写 W 星或写西塔星都可以了因为那个 W 里面会有参数。So basically the equation, okay, to find the maximum number of 2 over W vector is equivalent to find the minimum value of W vector squared. Okay, the concept is the same. Okay. However, how to find such kind of W vector? Okay, so we see it right here. So the W vector is right here. We like to minimize it. Right? We're going to minimize it. However, we have a condition. We have a constraint, which is yi. It should be, I think, larger than 1, right? That is our constraint. So basically, we have a mathematical tool called Lagrange multiplier method. 就是我们有个数学的工具就是拉格朗日法。它的意思就是说，我们在算最小化、最大化的时候，如果它刚好还包一个 constraint 的话，那你要怎么样去做这件事情？那公式就是下面这个样子。Okay, we will not go over how Lagrange ML and Lagrange multiplexer method. How do they derive these things? Okay, you can go to Wikipedia. Okay, the above problem can be transferred to the below one. Okay, Wikipedia has a very clear explanation how Lagrange do such kind of optimization problem with constraints. Okay, so actually we try to find this one. Okay, so here it is. So we can find the W star and B star, which is the optimized parameter. Okay, which we can find this line. It's a support vector line that can lead to maximum value of W squared, W vector squared. Okay. 我们不会太在意，就是计算要怎么算出来。反正我们已经知道 SVM 的概念就好了。它的概念就是找出那条线啊，找出那条线很简单嘛。两边找一个辅助线能够碰到两侧的 support vector 啊，两侧的 support vector 刚好可以画一条线出来去做那个垂直的投影，刚好就会得到宽度。那个宽度呢，刚好就可以符合一个最佳化的算式，然后 with 一个 constraint。啊，怎么算出那 constraint 那不重要，那个数学工具都会帮我们算，所以我们就可以基本上你把那些点全部输进去之后，那你刚刚说我要用 SVM 去帮我找那条线出来，啊，工具就会告诉你那个线的斜率跟那些 B 截距的值，这样就好。好，那个计算这件事情对我们来说没有很重要，因为套件都会帮我们算。OK， notice that in our class, okay, the derive or the calculation, how to find those W star or theta star, A star, B star, which is not that important because we have a lot of different tools or visualized tools can help us to find calculate those values. We don't have to calculate, we don't have to find out those values by ourselves. Okay, the only thing we need to do is to input the purple data point, the green data point into those tools. And we say, okay, I would like to use SVM. Would you please help me to find this green line? And help me to find the support vectors, which is x minus 8 and x plus. And those tools will follow those mathematic things. Okay, follow these mathematic methods to help us to find, okay, they will show us what is optimized W, what is the optimized B, and what is the x minus and x plus, which is a support vector. That is good enough for us. We don't have to calculate by ourselves. We use tools, we use computers. Okay, so that is the basic idea of SVM. Okay. So basically, if we have such kind of tool, so what is the difference between SVM and support? Okay, what is the difference between logistic regression and SVM? First, the same. Okay, usually logistic regression, they will try to find target. Okay, it is a binary target. The same, SVM is trying to find the binary target. Okay, but usually we don't use 1 and 0, we use +1 or -1 because in the surface, okay, one side is larger than the line, the other side is less than the line, which is what we call -1 or +1. Okay, but it is the same. For human beings, it is the same. -1 + 1 is nearly equals to 1 and 0. Okay. Of course, they accept different features. Those features are numeric features. Because we do this calculation in the surface, in a space, and those data points can be calculated, so they should be numerical. 就是我们不管是 Logistic Regression 还是 SVM 嘛，他们的数学原理还是做加减乘除嘛，还是做曲线嘛，那这边还是做这个线的切割嘛， 所以里面的 data point 啊，那些 x 啊，还是要按照数线那样子排嘛。啊，你要按照数线那样排的话，它就必然还是一定是小数点的数字，就是还是 numeric 的数字，对吧？那么就是有的时候这件事情啊，其实我们越走越后面，比如说你在10几周之后，有时候你根本就忘记这件事情。你拿了一个资料，然后里面东西不是 numeric 的时候，然后你就说好，我现在要套 SVM 用，啊，就没有想，你就一定要千万要记得回想这件事情，就是说。当时 SVM 在导的时候，里面明明就全部都是数字啊，为什么现在可以拿一个 categorical 的资料，然后就好像 categorical 的资料可以做加减乘除一样，不行啊，对不对？红色跟黑色怎么相减呢？啊，刚刚不是在那个 SVM 的数线上，我们要算那些 projection 啊，那些投影啊，那些向量吗？那红色跟黑色怎么相减？不行啊。有时候你走到越后面，或者你以后把这些基础数学都忘记的时候，你会发现你常常会不小心这样用，可是这不能这样用，其实没什么数学背景，好，就是不对。好 One thing you have to notice that, okay, when we derive how to find the best line of SVM, okay, those things, those numbers are all numeric, not categorical, right? The features are all numbers, so that we can calculate the vectors. We can calculate how to do the projection, how to minimize those values, how to use the range method to help us to find the solution of the optimized problems. However, maybe after a few years, okay, you know SVM can do a very good model to do classification. However, you might forget SVM, okay, based on this derivation, 就是它的推导结的流程. It only accepts numeric features because when we derive SVM, okay, all those things are vector based, are numbers. We cannot subtract a blue color from yellow color. Blue color and yellow color, they are categorical features. They cannot put on the axis, 就是 axis 就轴嘛。So remember that SVM can only deal with numeric data, basically. Okay. Of course, there are several variants of SVM which can deal with categorical data, but that's not the SVM we talk about right here. Okay. SVM 当然它会有很多衍生其他不同版本，然后或许就可以处理 categorical data， 但是我们现在讲这个 SVM 就不行，因为它导出就不是这样导的哈。Okay. Well, 8 minutes, so we take a look at the following example, okay, by how SVM deal with it, okay. You can either download this data from my GitHub, okay, or you can download it from my Google Drive, whatever you want, okay. So basically it is a table, okay, so and from 0 to 682, so we have 683 different rows, different data, okay. It has 10 columns. I think it's 9 plus 1, 9 features plus 1 target, okay. So let's take a look right here, okay. The target name is type, and in this example we only select 2 features to perform SVM. That is easier, okay. So we select feature 0, feature 1, which is the cell size and cell shape. Okay, this problem is called breast cancer problem. Okay, so it's quite easy. We have such data, okay, x0, which is the size, s1 is the shape, and we have a y target, which is type. Okay, we'd like to know what if it is cancer or it's not. Okay, so basically, okay, you can see line number 4 and line number 5. That means, okay, the tool, okay, please help me to prepare a SVC. SVC stands for support vector machine. Okay, so machine. And the kernel right here, it says line linear, which means I would like to draw a line, as we introduced before. Okay, we will talk about C before later. Okay, so I give the feature which is right here. So here that is right? That is the feature right here, and here that is the target. And I simply just input those features, those target, to this we say this algorithm, this function, and suddenly, okay, they tell us, okay, here is the coefficient and the intercept of the support vector machine. So here, that is W, which is and B, it's right here. So that is the answer. That is a line which can divide those 683 medical record, 就是医疗记录. Okay, that can clearly separate different Y， 就是Y， 就是它其实没有怎么样，反正你给它数据，它就直接告诉你那条线在哪里，就这样子。Okay, so there's another things you might want to know. That is, then where is the support vector? So it has a lot of support vector right here. Right here. So those line will touch the support line of the SVM. Many of them. Okay? 就是这些点都会刚好碰在那个两条那个虚线上哈。Okay, that is. There are total 28. So that is x minus, that is x plus. There are total 28 points which belongs to x minus, and the other 27 their points belong to x plus. 好，所以你会发现那条线其实碰到蛮多点的哈，就是反正有600多个点嘛哈，在那个界线上就有20几个点碰在其中一个辅助线上啊，另外27个点碰在另外一边的辅助线上啊。So that is okay. That is. Let's stop right here, okay? And we will talk about how to evaluate different models by using Orange. So we will come back 10 after 10, and we will introduce Orange again. Okay, if you have installed Orange, try to follow me. Okay.